Good morning, friends. We're going to be reviewing the content for our final. So starting off with these equations, we have 1 over x squared equals 3 over 2x minus 1 over 4x squared. So the first thing is looking at our denominators. It's going to be easiest to pick the term with the greatest denominator and then multiply that denominator to both sides so that we're able to further simplify. So in this case, 4x squared has the greatest degree and is the greatest number. So we're going to use 4x squared and we're going to multiply it to both sides. And what that means is 4x squared times 1 over x squared equals 4x squared multiplied by 3 over 2x minus 4x squared times 1 over 4x squared. So what I did is I just rewrote it with 4x squared being multiplied to each of these terms. So let's rewrite. X squared cancels out, we're left with 4, and it equals 2 goes into 2 once, 2 goes into 4 twice, so 2 is still here, and then x goes into x once, x into x squared once, we're left with another x. So we have 2x, and 2x is still in the parentheses, so 2x times 3 is 6x, and then minus, these cancel out, we have 1 left, so it's going to be 4 equals 6x minus 1. So let's move everything let's move all the x's to one side and the terms to the other side. So 6x to the left, it's going to become negative 6x, and then we're going to move 4 to the right side, so minus 4 from both sides, and we're going to have minus 5. So then we divide negative 6 on both sides to isolate the variable and solve for x, and we're left with 5 over 6. So our solution is going to be 5 over 6. Okay, for the next one, this has the greatest degree, so we're going to use this and multiply the sides by this number. And the reason why we're multiplying by the greatest denominator to all the terms is so that we're able to further simplify and cancel out any denominators that will make it easier to solve for our solution. So that's why. And let's rewrite it. So 2x squared, 3x minus 12 over 2x squared equals, 2x squared times 3 over 2x plus 2x squared times 1 over 4x. This cancels out, so we're left with 3x minus 12 equals, this cancel out, only 1x cancel out, so we have x inside still, x times 3 is 3x, plus, and then we have 1x cancels out, and then 2 goes into 4 twice, so we have x over 2, and x times 1 is just x, so. Okay, now we have 3x on both sides, so we can cancel that out. Also because they're on opposite sides, and they have the same sign, they're both positive, so we cancel them out. Okay, so now we have negative 12 equals x over 2. Multiply 2 on both sides to cancel this bottom out, so we're left with negative 24 equals x. So our solution for this one is negative 24. Okay, so for this one, what I'm going to do is I'm going to move this term to this side. So 1 is going to be on the right side by itself, and I'm also going to simplify and factor as much as I can. So let's see. So we want the numerator to be the same, so let me erase this. this denominator here, we can actually simplify. We can factor x out, it'll be x minus 2. And then we can see how x, or this is equal to that. So we want the denominator to be the same, but we're missing an x over here. So what we can do is we can multiply x to this term here, and that would multiply the top and the bottom by x. Yeah, let me write that out so it's a little more clear what I mean by that. It's going to be x multiplied by the numerator over x multiplied by the denominator, and then minus. So it's going to be a common factor now, so we are able to write it. No, why can't I move it? Okay. So now so I was able to, combine these terms, because now that the denominators are the same, as you can see here. So I wrote this over here, and then this right next to it here, and then they share the same denominator, and we just have that equal to 1. Okay, now I'm gonna multiply this x in, and then rewrite. So we have 6x squared plus 18x, and then same thing over here, we didn't touch it yet, so it's just going to be the same thing, plus 180 over x minus 2 equals 1. Okay, so now what we need to do is solve for our x. So before we can do that, we're going to need to combine our like terms. So here we have 6x squared and then negative 5x squared. So we can combine that to be x squared, because 6 minus 5 is 1, so it's just x squared. And then 18x and negative 60x are going to combine to make positive 78x. And then 180 is still there. Hold on. Okay, so this is going to be negative, because I forgot to show this, but this is the term, this part here, when we moved it to the left, it became minus. It was minus. So minus, or negative, whatever, is the sign for the entire term. And so there's that minus sign, and it applies to the entire term. And then down here, it's just going to multiply in. And then I combined it to get this. And our denominator is still like that. Yeah, so it was 18x plus 60 is how I got 78, and then 180 becomes negative because we're multiplying this negative in, and all that equal to 1. And now we can, what can we do? Get rid of the denominator, so multiply both sides by x minus 2. So that gets rid of our denominator, and here we have x squared plus 78. X minus 180 equals x minus 2. And this would give us 2x, or x squared minus 2x, right? Yeah, so this here is going to give us x squared minus 2x, And so we can cancel out the 2x, and we're left with 78x minus 180 equals 2x. So what I'm going to do now is move 2x over to create a trinomial so that we can factor it out and then get our solution. So negative, not negative, 78x minus 2, no, 78x minus 2x minus 78x, hold on, sorry guys, 78x plus 2x makes 80x. Oops. 80x. Okay, so we have 80x equals negative 180. Now I'm going to move the 180 back over and then isolate to find x. So we have 18. We have 18 over 8, which simplifies to 9 over 4. So our answer is 9 over 4. So let me just summarize again what happened. So what happened is we moved this term over to this side, so it became negative, and then we factored out the denominator so that we could get it to match the inside here. And since it was missing an x, we multiplied x to the top and bottom of the left side, which doesn't change anything because x over x is just 1, and 1 times anything doesn't change it, so that's why we're able to do that. And then we rewrote all of it over here, so we have our numerator here and then this other numerator here, and it's minus, so we keep the sign, and the sign we distribute it into everything else, and then we combined like terms to get this, and then we multiplied our denominator on both sides to get rid of it, and then over here 1 times that, and then we factored in our x to get this, and then we canceled out our x squared on both sides, and then we moved 2x to the left side, which made it positive 2x. Positive 2x plus 78x gives us 80x, so you have 80x minus 180. We moved 80 to the left, which gave us positive 80, and then we divided 80 on both sides here, and then that left us with 18 over 8, x equals 18 over 8, which simplifies to x equals 9 over 4. Hopefully that made sense. So let's do another one. We have this one. So same thing, we're going to want to multiply our greatest degree denominator term to both sides of the equation, which in this case, pretty obvious, is that. And so I'm going to multiply that to both sides. Over here we have 1, so when we multiply it, it'll just be, it won't change, it'll just stay like this. And it's going to be plus wait. This we can factor it out to k plus 3 and then k minus 1. And so for this one, this is the same thing as this. So I'm going to multiply this to this term here, and you will see why. I'll put it all into parentheses so that it's clear that I'm multiplying this term only to that. Where was I? Oh, times 1 over k plus 3, and then k plus 3 cancels out. So that just makes it easier when we go to rewrite. It'll just be k minus 1. Now I guess it's easier to see and understand also. and it'll be equals 6 because when we multiply both sides by this denominator, it cancels out this denominator. So it's just going to be equal to 6. And so let's combine like terms now. So k squared and then 2k plus k is 3k. And then minus 3 minus 1 is minus 4 equals 6. Let's move 6 over. 6 minus 6 from both sides. So we're left with k squared plus 3k minus 10 equals 0. So we can factor this out to be k plus 5k minus 2 equals 0. We did this like way at the beginning of the year. So just like quick review. When you have a trinomial like this, which is where you have 3 terms, with which is a second degree, and then it descends, we have k squared, k, and then just a term. You can factor it out like this by looking at the last term. So in this case it's negative 10, and then thinking about the factors of it. In this case I used 5 and 2. And then you want something that adds to make your middle number, and obviously it's going to multiply to make this, and so we know we need one positive and one negative to multiply to make this negative number. And so I just look at my factors and see what do we need to do to make it 3. You need to subtract 2, because if it was minus 5 plus 3, that would be negative 3, which isn't right. We have positive here. So we have those 2 terms, and then we just put them in, and you're left with that. And so k is equal to 2 and negative 5, because you're going to want to set both these to 0. And when you set k plus 5 to 0, you get k equals negative 5. When you set k minus 2 equals 0, you get k equals 2. So that's the answer for that one. Should we keep going? Yeah, okay, let's graph, and then I will make a second part for the following stuff. Okay, hopefully that's enough room. So first we have this function, and when you want to graph a rational function, there are a few things that are required to graph, and that is the vertical asymptote, the horizontal asymptote, the y-intercept, the x-intercept, and then if there's a hole on your graph. And so I usually start with looking at my function and then seeing if there's any way I can simplify it, which in this case we can simplify to this: x minus 3, x plus 3. It simplifies to that. And so these 2 terms cancel out, and what that means is that tells us what our hole is. So x minus 3 is what canceled out. We're going to set it to 0, and we get x equals 3. So there's going to be a hole at where x is 3, and in order to determine where y is, we're going to need to plug x, which is 3, back into our equation. So this one actually is this now. So we can just plug it into this. So everywhere we see x, we're just going to replace it with 3. And then what you get is your y coordinate, which is 2 over 3. So there's going to be a hole at 3, 2 over 3. So let's plot that on our graph. So 3 is here. 2, 3 is like here-ish. And we represent that with an open dot, but in reality, it's like a really, really small open dot. But I'm just going to exaggerate it so we can see. Okay, now let's do the vertical asymptote. Vertical asymptote is solving for the bottom, which in this case is x plus 3. So x plus 3, you can set it to 0, and you get x equals minus 3. So your horizontal asymptote is minus 3. Your vertical asymptote is minus 3. And then let's find our horizontal asymptote. And then another review. When finding the horizontal asymptote, when the top and the bottom degree is the same, which in this case it is, the horizontal asymptote is going to be the coefficient of the numerator over the coefficient of the denominator. And so in this case, it's going to be 2, because 2 over 1 is 2, and so that's going to be our horizontal asymptote. Okay, next we need to find our x-intercepts. So in order to find the x-intercepts, you're basically solving for the top. Well, you're solving for the function, but the reason why it's basically the top is when you set the function equal to 0 and you get rid of the denominator, you'll just be left with the numerator equal to 0, because the denominator times 0 is just 0. So let's solve for the numerator, which is it 1? Yeah, because we have 2x minus 1 equals 0. Divide 2 on both sides. 0 divided by 2 is just 0, so you have x minus 1 equals 0, x equals 1. So x-intercept is going to be at 1. And okay, and then your y-intercept is when x is 0. So back to our equation let's see when y is, or when x is 0. So plug 0 into where we see x. And what you get is minus 2 over 3. So that's our y-intercept, which is like here. Oh wait, it's like here. Okay, knowing that, we can draw it now. So that's that part. And then usually this is just going to be a rough sketch. If you want to get a more accurate point of where the other half of the graph is, you can plug in a even value or an easy-ish value into x to find y. But for the most part, you can just think of it as the graph gets really close to the horizontal asymptote and really close to the horizontal asymptote at some point, but it never touches it. So you just need to draw kind of like a curve that gets closer and closer to those asymptotes. And that is enough to be able to find the range of domain, which in this case it isn't asking us to find, so we're not going to find it. Okay, so for the next one, same thing, holes. Starting off with holes, there's going to be none because there's no common factor in this case. Vertical asymptote, we're going to solve for the bottom, so 2x minus 2 set to 0. 2x equals 2, x equals 1. So your vertical asymptote is going to be at 1. Okay, and then your horizontal asymptote, in this case the degree is the same, so it's going to be the numerator coefficient over the denominator coefficient. So you have y equals 1/2. It's like here. Okay, and let's find the x-intercept. So solving for the top, x equals 4. And then y-intercept is where x is equal to 0. So we're replacing x in our equation with 0. Two times 0 is 0, minus 2 is minus 2. So you're left with 2, which is your y-intercept. And this graph, it's nice because we can see, like, get a more accurate thing for both sides of a graph. So you just want to have your graph, what is happening? Get really close to those asymptotes, cross the x or y intercept, and then continue close to the next intercept. So that's that. Next video to be uploaded will be this bottom part, and then probably like this section. Yeah. Bye guys. See you soon.